Good morning. Hopefully it's working. Okay. Saturday. Finally Saturday. Okay, let's continue the things about the motherboards. We done some practice, yeah. But now is the time for theory. I know. The theory. Everyone is running out when it's about the theory. Let's open a laptop schematics, yeah. Let's have a look. Let me be sure it's on screen. Okay. So here we have a laptop schematic. Okay. Good. You know, I avoid to fixing motherboards with schematics because the schematics is not enough. You need board view also, and the board view is more hard to get the things, you know. What do we have here? We have like a basic schematic of a motherboard, yeah. You have the memory, you have the CPU, the chipset. We have few things here, but just general things. Let's go further and check. Clock generator, because you need a clock on the motherboard, yeah. CPU. DDR3 socket. Switch button. You see the start button, the power button. LCD connector, LEDs, the VGA connector. That's the chipset. Good morning. Okay. Hard drive connector, Bluetooth. You know, I'm looking for the power supplies because most of the time that's the problem. Thermal fan connector. Audio amplifier connectors. BIOS. You see the BIOS? We spoke about the BIOS. Clock data on the pin number 8. You have the plus, the VCC. We spoke about that. Yes, yes, we'll learn something today, yeah. Thank you. Okay, let's go on the power supplies. Because most of the problems comes from the power supplies. That's are the Mosfets. Okay, that's a power supply, yeah. Let me make this bigger. Okay. So what do we have here? we have the Mosfets, yeah? And if you check the Mosfets, so you can see you have 4 pins, yeah, which is drain here, yes, are all together. Source, you have 3 pins, and you have gate, 1 pin. That's why the Mosfets, they have 8 pins, 4 pins each side. And you have two Mosfets here, yeah. Also, you have the coil. We spoke about the coil in the last video, yeah. The coil is here. That ceramic capacitors are here. VC battery out. Okay, and the electrolytic capacitor after the power supply on the output. This power supply, it's a 5 volts one. Also, these chips are controlled by this big chip, and he can handle 2 power supplies. Here we have the second one, yeah, same, 2 Mosfets, the coil, the ceramic capacitors here, yeah, and the output capacitor. That's what we spoke. If you didn't see the last video, just check the last video with the motherboards. This is the path to find the power supply on the motherboard, yeah? 2 Mosfets, the coil, the ceramic capacitors, and the big output capacitor. What I want to speak about this, you have a lot of wires here, yeah? This from the middle, you see, this they have 3 pins here together, and here 4 pins together. And it's going inside obviously from here is the coil and the output, but also you're going on the chip. This is the phase detector, yeah? And this from here, you see this is on the output, yeah? You have 2 capacitors on the ground, and you have these things, yeah? It's a resistor who comes back to the chip. This is the feedback. Obviously this chip should know what happened on the output, what voltage is there, to keep the voltage stable. So that's the feedback. That's very important. Let's go on different one. So this is like a power supply with two power supplies. This is 2 power supplies. So actually you see 2 power supplies, but it's only 1 chip, 1 controller, driver, yeah? That's not hard. Let's go on the other one. This is different one, same thing. Exactly what I told you. You have 2 Mosfets, you have the coil, the feedback, and this chip, TPS, yeah. This chip is controlling the power supplies. Easy. What we have here? This is different voltage. PDR, VREF. Okay, another power supply. This is a Acer Aspire 3935. So that's how you read the schematics, if you want to work with schematics. But exactly what is on this schematic is on the motherboard. And it's on all the motherboards. So it's like a path. So we have 2 Mosfets. It's the same, and this is a ICL chip. ISL, sorry. You have the ceramic capacitors here, yeah? The Mosfets, the coil, and the feedback. This is power supply, 6.5 amps, VGFX, probably it's graphics, can be. This is another power supply. Think this is the battery one. DC battery out. And you have a current sensor here. Yeah, possible. So you see, this is the same, a power supply, yeah? But here we have a resistor, a small resistor there. It's called current sensor. It's a small resistor, and you see you have two signals who comes from the resistor on this chip. Actually, this chip is reading the voltage on this resistor, and this way he can read the current output. Obviously, if this is the battery plus, usually the battery is charged with 10% from the battery capacity. So let's say if we have 10 amps battery, so the battery will be charged with 1 amp max. If you put more power on the battery will get hot and the life will be shorter. Let's see what we have here. This looks like an input, and here we have AD plus. Probably here's the charging port. That's my first MOSFET. Here we have another current resistor. VC battery out. Where is the second MOSFET? Why it's only one? Let's check. Okay. This is the battery connector, and we have plus. And what we have here more? We have the data, we have the clock, main battery connector. We'll speak about the batteries, buttons, and that's all. Okay, so basically we see how a power supply is looking on the schematics. It's nothing hard here to be understood. So we have the MOSFETs, two MOSFETs, coil, ceramic capacitors, and the output capacitor, which is not ceramic, it's electrolytic, yeah? The problem is most of the problems comes on the parts where they are getting hot, or they are working with high amperage, like the power supplies. You can have short MOSFET, or you can have short capacitor. I found a lot, you know, short capacitors, short MOSFETs, so you can have this problem. It's no point going and speaking about some random resistor, because he will not get burned. The chip, yes, I found the chip, you know, the MOSFET controller to be burned, yes, I found it. But if you go on the motherboard, you see the power supply, yeah? And the power supply, let's say, has no output. The 3.3, let's say because the 3.3 it's always on the voltage. It's always on. So if it will be something to die, probably the 3.3 volts power supply will die first. So if you have no output on the 3.3 power supply, you check on the chip if you have voltage. You should have 19 volts, because you see this is DC battery out. Goes on the battery connection with the charging connection together. If you have voltage on the chip, you can check each chip, you don't need schematics. You check on each pin and see if you can find 19 volts. If you have 19 volts but no output, yeah, probably the chip is dead. If you don't have 19, well, you have 19. You know, it's 19. It's on the main thing. You should have 19 on all the power supplies, even if the laptop is off. Yeah. So this is a 5 volts power supply. Yeah, we can see here 5 volts, probably USB, probably the hard drive. And on the other side we have 3.3. Look, that's 3.3 power supply. That's 3.31. Okay? Good. Now let's draw the laptop schematics. So we spoke about on the last video about the hardware. Paint. Okay, let me be sure it's on screen. It is on screen. Good. Size, okay. So let's see, we have the DC jack, yeah? So now I'll draw the laptop schematics. How I see the schematics. So here we have the DC jack, yeah? We have the middle pin and we have the round connector. This is ground. I'll not draw the ground because ground is everywhere. And this is plus. Here is plus. Here is 19 volts. Yeah? Plus. That's plus. The first will be probably you'll have some resistors, some fuses, but it's not important. I'll not even draw that things. You have a Mosfet, yeah? Let's say you have a Mosfet. That's my Mosfet. And we have 4 pins. All these 4 pins are together here. Yeah? 4 pins. On the output you have 3 pins. 3 pins is the output and 1 is the gate. This is the gate. We'll speak later on about that gate. These are all together. Yeah? The next one is another Mosfet. You must see these things, yeah? Like a switch. And my mouse is not working. It is working. You should see this like a switch. Let's make a switch. Because actually it is a switch. Nothing else. It's a switch. This again. 3 pins. And the pin number 4. Gate. And here we have 4 pins. All together. Yeah. Warning. And it's on all the laptops. Even on the MacBooks. But the MacBooks are different. That's the switch signal, yeah? And the gate, let's say the gate is moving the switch. Yeah? Ah, sorry. Yeah, no, that's wrong. How can I erase? That's wrong. Oh, come on. In a different size? Yeah, maybe. Okay. Maybe brush. And that's the gate, yeah? So what we have here? We have 2 gates, 2 pins. If you apply voltage on that things, you can open or close the switches, yeah? I will do a battery schematic, just wait, yeah? I will speak about the batteries and chargers. These pins go probably on some power management chip. But that's not very important. What this power management chip is doing, few things, but keep in mind it's something very important. This management chip also check the input voltage, and I will explain you after why. Power management page. Okay, I will speak about that. After that, after these two MOSFETs, I have a resistor. And also I have two connections from here, and I have one more connection from here, going here. This is it's the value of this this resistor. It's low. It's like, let's say 0.5 ohms or 0.1 ohms, 0 point something ohms. Yeah. And this is my VCC that from here is going absolutely everywhere. So let's say, and also I have one more MOSFET. 1 second. One more MOSFET here. Three pins all together, and the gate, which is also going here. And here I have the 4 pins all together, and that's going to the battery. Yeah, battery. Good. There's no point speaking about the ground. Ground is everywhere. So from here, yeah, from this big point, let's jump over this thing. From here, that's my VCC. Yeah. How this thing is working, you know, before going further, you know, before going on the power supplies, because most of the problems are here, you know, are here on this rail, on the power rail, on the 19 volts. I have 19 volts. This is my first switch. This is the second switch. What these are doing? These are like emergency switches. If you keep press the power button 10 seconds, these switches, yeah, will get open and will cut the power. So this is like a wires. When everything is fine, this is like a wire. It's no voltage reduction or something like that, or nothing. It's like a wire. That's these switches, yeah. So if you keep the power button pressed, if you have this also has a connection with the thermal of the laptop. So if you have overheating, this switch will switch the laptop off. If you have a short on 5 volts on the USB ports, this switch will switch the will cut the power off. Yeah, will cut the power down. If you have over voltage here or under voltage, so if you go, let's say, I think the laptops are working like up to 24 volts. If you go higher, probably this chip, which is reading the input, yeah, will cut the power down. If you go under like 17 volts, I think this chip, yes, will cut the power down. On the other hand, obviously if you have a short on the motherboard, yeah, anywhere, you have a short here, you have a short, because here you'll have all the power supplies, you have a short. Doesn't matter what, you have a short. This current resistor will tell to this chip it's a short, and this chip will cut the power down, you know. Obviously, if you have here a short, the voltage on this resistor will be high, and the chip will read this. What I done in few videos, yeah, I just jump over the MOSFET. You can jump over the MOSFET. Let's solder a wire from here. Even from here, and you have like a straight wire here, it's not a good idea, but it's good to identify the fault. Because you don't know if maybe this chip is faulty. Maybe everything in the laptop is fine, but this chip is faulty, and I don't know, maybe one MOSFET is faulty. You never know. But anyway, if you try, let's say the easy way, yeah, the easy way to avoid playing with this, making short here or replacing the MOSFET. Let's say come with the 19 volts for the from here coming straight here or here will not work because this chip is reading the input. I tried before. I said, you know, let's come with 90 volts here or here. Where are all the power supplies? You know, just jump over all these things and comes with the power supply here on this point. Here, I said, let's put 19 volts here and let's see if the laptop is working. It's not. That's the thing. It's not, because this chip is reading the 19 volts here, and also this chip will give a signal to that startup chip. So if you put a voltage here, it will not work. So don't try it. I tried already and it's not working. Okay, so from here, what do we have? We have all the power supplies. So that's clear, yeah? When we have the power flow is like that. That's the power flow, yeah. That's the power flow, come here, and also, yeah, is going and is charging my battery. And this chip also is controlling the charging current on the battery. I'll tell you what you don't have to do. This is when the charger is plugged in, yeah? You see these arrows, yeah? When the charger is plugged in, and also is charging the battery. When you unplug the charger, yeah, you'll have this voltage from the battery coming here. That's the way how the battery and charging is working. When it's plugged, it's charging the battery. When not, it's the voltage from the battery is come back on this point. And the battery, let's say you have 4 cell battery. 4 cell does mean 3.6 is the lowest times 4, 14.4. Probably you don't have that. You have 3 elements. 1 second. So you have 3.6 are lithium elements for free. 10.8. 10.8 that's mean fully charged is 4.2 times 3 equals 12.6. So your battery will be 10.8 discharge like 0, yeah, 0 volts. 0%. 10.8 volts, and fully charged is 12.6. 12.6. And now you'll ask me, yeah? Sorry. I will show you where is the power button connected, yeah? Now you'll ask me, if the laptop is working from 10.8 to 12.6, yeah? Why on the input, on like 17 volts, this will cut down the power? It's working, so your laptop is working even with 10.8 volts. So the power supplies, they will work even with lower voltage. But actually this chip will cut the power down probably around 17 volts. Because if cannot charge the battery, yeah, he will cut the power down. Good. So that's the power on and charging, yeah? That's clear. The power supplies. This paper is too small. We have first the 3.3. That's always No, all the power supplies are under the voltage, but the 3.3 is always on. Like we spoke yesterday in the video with the motherboards. When we have graphics and CPU in one chip and no video output. You know, you know, I don't want to use bad words, but on that moment you have a big problem. If let's say if you are lucky to be the RAM memory, you can be lucky to be RAM memory. If not, you have a big problem. Can be the processor. You know, it happened. You have the processor and the graphics on same chip. If you play with the screen connector, yeah, you can burn the graphics from the processor. And you see the laptop is coming on, but it's displaying nothing. That can happen. You can try with different processor. But okay. So we have the good. Let's say we have the power supply 3.3. Yeah, that's the power supply. We'll speak after about the power supply 3.3 volts. Yeah, that's always on. This power supply is always on. And we have the other power supplies. We have many power supply actually. We have the startup chip. Let's say that's my startup chip. Yeah, this can be at IT ENE, yeah, can be SMC, sorry, or Winbond, and a few more. The worst from this one is the SMC one. This chip is getting in short. If you have a SMC chip, yeah, it can be on short. I found many on short. This chip actually, it's always on 3.3 volts, yeah? That's a controller. That cannot be faulty. Yeah, maybe it's erased, maybe it's an error on the program, but I didn't find like a BIOS chip faulty. But yeah, can be corrupt, you know, the program from the BIOS. And also we have the BIOS chip, yeah, BIOS. Okay, which is also at 3.3 volts here, yeah. Okay, what this chip is doing? One is reading the power button, and the power button is connected to this chip, yeah. Let's say this is the power button. Here we have a resistor, a small one. Also, yeah, here we have a resistor, and all the laptops are the same, yeah, to 3.3. So this resistor is keeping me is keeping this pin always on 3.3 volts. The condition to this chip start is this pin to be to ground, to move the 3.3 to ground. So here you have the power button, and the power button is exactly on this way, yeah. You have the power button like that. That's a switch, yeah. That's my switch, that's the power button, and this is to ground. That's always, you saw in the videos, I make sure between two pins to start up the laptop. To start the laptop, yeah? So if you push the power button, you start the laptop. That's exactly how the power button is connected to the motherboard. So you can make short. It's not a problem. Even if you make you don't have most of the time you have a ribbon cable from here. From here to the power button you have a ribbon. You can make short from here, from this pin. If you check with the multimeter, you'll have 3.3 volts because you have this voltage, yeah? And also the pin is not going straight in the chip, so you cannot damage nothing. You can short it to ground. You can short that pin to ground to start up the laptop, yeah? That's the power button. Power button. That's the way how this chip is working. Also, this chip is doing more things. After you press the power button, yeah? You press the power button. The computer is a dumb thing. He doesn't know what to do. He will read the BIOS, which is a basic program, yeah? He will test this chip. He will carry some tests, few tests, yeah? Few tests. And he'll start the laptop actually. This chip will start all the power supply, yeah? You'll power up all the power supply. And we have from here, let's say that's my 5 volts one, yeah? 5 volts power supply. Here we have 5 volts. This chip will order this power supply to start. We have we can have even a 3.3 big one. 3.3 volts. We have the CPU, 0.9, 1 volt, depends on the CPU, yeah? And these are all together connected here. You see here. What do we have more? We have what power supplies we have? Can have more power supply. 1.5 RAM. 1.5 volts. Yeah. All are from here. All this power supply. That's what I told you. First, check if you have voltage on the power supply on that ceramic capacitor or on one side of the Mosfet, yeah? So you always should have 19. Yeah, the power supplies probably are not working. Because the power supply will start working when you press the power button and this chip will start all my power supplies. Yeah? What this chip is doing more is bring the screen to life. So this is very important because we have two important signals here. You have the VLED. So I know from the experience what are the problems. So you'll have a problems with this VLED and power on, let's say. But this can have different names. Power on. On the screen, yeah? Screen. Okay, let's make the screen here. That's my screen. You have the data, but we don't care about the data. We're not speaking about the data. The data is going to the graphic chip or the processor, yeah? What voltage important do you have there? You have 3.3. Yeah? Where is the 3.3? Let's say from this. Which one is ITE? No, can be one of these chips. So it depends of the brand of the laptop. You can have ATA, ITE, ENE, SMC, Winbond. You see? So you can have only one. Only one from, but all are doing the same thing. So you have the screen, LCD, yeah? LCD. No, it's not LCD, it's LED. LCD you need an inverter. No LCD. We'll speak about the LCD. Most of the screens are LED. And you have the data, yeah, that's the data pin. On the data size you have 3.3. Let's say it's coming here, jumping, and it's coming on this output, 3.3 volts, yeah. And we have 19 for the inverter, for the light. So that's the data, 3.3 and the data. Yeah, that's what we have to check if you don't have picture, but you have light. On the light side, you have 19, which is coming from here, same point, yeah. We have these pins, you see these ones, which is coming from this chip. That's the thing. And we have one more pin. Sorry, I'm not going on drawing. From here, yeah. So you have to understand how this thing works. After this chip is making the auto test, yeah, the startup chip, will power up the screen. If see something from your laptop is failing the test on the startup procedure, you know, when you press the power button, these they will not give the signals on this pin. So on this pin I should have 3.3 if everything is fine. 3.3 volts. 3.3. Yeah. But this is one is power on, one is powering up the screen, one is the dimming. You know, the screen is making less brighter or brighter. Yeah. So on one pin you have 3.3. If on the other pin you have 0, you have no light. If you have 1 volt, 2 volts, yeah, you have low light. So that's very important on these two pins to be signals there. Yeah. But this is a LED screen, yeah. So we are not speaking the big inverter from LCDs. But even on that one, it's same thing. Yeah, you have right, it's same thing. And I found this like this chip is not giving me any voltage on this thing. And what you can do in that case, and I explain, I have like a maybe. Yeah. We have a laptop. We have I think a Samsung, yeah. And was a problem with these signals, and what we done, we short these pins. I know it's dodgy, but that's the only way to fix this problem. We short these pins with the 3.3 volts. So from here we short that pins, jumping over and moving here on the 3.3. So actually you just have to solder the pins. You have test points on the board, on the screen board. You'll have test points saying power on, VLED, LED on, things like that, LED on. You'll have test points, and you can find very easily these pins. So all the screens, they have test points on this pin. Here on the board you'll have like a round things, and it will be a writing there, and on the writing will be this: power on LED, LED, dim, light on, things like that. Depends of the screen. But here you'll have test points. Test points are some things make here for you to check. Obviously if you have 0, it's not okay. Also when you have graphic issue, obviously the board will fail the test and the screen will have no light. So when you have no light, you probably have a graphic problem, or you have no memory. Will fail the test. It doesn't matter if the thing will fail the test, the screen will not come. You will have no light. That's a sign. If you have light, that means the board passed the test. If the board passed the test, probably you have a ribbon cable issue, or you have a screen issue, but not the board. So that's the first thing when you check a laptop. See if it has light or not. That's very important. Because based on these things, if the screen has light or not, you can put a diagnostic. Of course, if the screen has light, probably I will say like 100% it's a screen issue. And that's what I will do. Probably no. I will check I will see the if the screen has light but no picture or lines or things. The next things I will check with the external screen. You see, you have the external VGA connector or HDMI. You just plug and check on the external screen if you want to check. Okay, and also this chip will read my keyboard. Yeah, here is my keyboard, and this chip will read all the keys. Yeah, keyboard and also the touchpad. Keyboard, touchpad. But this is doing a lot of things. This will start the Wi-Fi for me. Will start the Bluetooth, Wi-Fi, Bluetooth. It's doing a lot of things. So this is bringing to life all the motherboard, and also it will bring me the chipset. The chipset. Chipset. This chipset. It's this is a smart thing, you know. This is doing a lot of things. So all like USB. Let's say you have USB are managed by this chip. The SATA, the hard drive, yeah. Also, as is communicating with the processor or the graphics, we have the, let's say, the processor. From the processor it's managing the memory reading and writing, but the switching is from this chip. So they are all working together. Also can have the graphics, you know, the integrated graphics Intel. Yeah, it can be from here, or you can have a dedicated chip, or you have it's inside of the processor, and the data, this data thing is coming from here, from the chipset or from the processor. It can come from anywhere, or from a dedicated graphic chip. Yeah. Bypass the graphics. To be honest with you, I heard that some people, they are disabling, they found a modification how to disable the dedicated graphic chip and switch on the integrated Intel chip, but I don't know so much about that. So that's the basic. If you have like keyboard issue, touchpad issue, this chip is controlling the thing. Yeah. Wireless. No, wireless actually is connected with the chipset, but it's powered up by this chip. Same with the Bluetooth, because the power on signals comes from this chip. This the startup thing. The battery, yeah. The battery. I need a new one. You know, the people with the battery, they let me open a new one. Save. You know, the battery, it's a simple thing, but they make them so complicated. They complicate everything. So you have the cells. Let's see, you have the cells, and they complicate these things only to don't be like copied. You have 3 cells. Each cell is 3.6 volts. What do you mean? What do you mean required chips? Required chips for what? 3.6 volts. 3.6 volts. So all these cells, they have 3.6 or 4.2. 4.2 fully charged, 3.6 discharged. Yeah? Yeah, I see, but for what? That's what I ask you. From where you can get all the required chips. For the motherboard. Oh, you can buy from eBay, you know. If you have, you can get from different board. If you have board for spares. So all these cells, yeah, it's not about only this cell. Even the phone battery and tablet battery, all these things, they are lithium, yeah. They have 3.6 when are fully discharged, and 4.2 when are fully charged. What they done here? They use a board. And the board is something like that. You have two Mosfets. Let's say you have minus. Yeah, plus. No, that's plus, that's minus, yeah? Minus is the ground, okay. And on the plus side, you have two Mosfets. Same. And you'll find these Mosfets on each battery. 4 pins, 3 pins. And same like that. You have the second one. And actually this is the output. And from here you have a resistor, a current resistor, and you have the battery output. This, and from the ground you have the battery connector, yeah. These MOSFET, like how I said, are switches, yeah. This resistor, it's a low, it's probably 0 point something ohms, yeah. And this is a current resistor, and obviously you can read the current from this resistor. And here you have a management, you have a power management chip, which is what it's doing. And also it has a memory. You know what? Yeah, the memory. Now from here you have a memory, yeah. This is the power management. Okay, the power management, you have one here. You'll read the output also, and you have a memory. Often that main chip fails. Which do you call main chip? So which is main chip for you? Okay, so this power management chip here, yeah, what is doing? It's controlling the battery and is reading, you know, how much power go through this resistor, yeah. And also will shut down the things if you have any short on the battery connector. Will control the charging current, you know, if the charging current is too high, will cut down the power. And also from here, if you open a battery, you can see after each element you have a wire. And let's say based on these things, yeah, on the resistor, this power management chip, yeah, he will see how long it's taking to the battery to get discharged from fully charged to empty. When the times, so let's say the battery is discharging quickly, this chip will know, and this chip will report the battery, like you have the data, you have clock and the data. That's why you have the message, consider replacing the battery, or charging, I don't know, you have a lot of error message, or replace the battery, or things like that. So this chip will consider by himself when the battery is gone, and at some point he will cut these switches. So these switches will be never yeah, the gate, sorry, the gate is controlled by this chip. So yeah, at some point he will disable the battery. But you know what, this is electronic. Here probably is nothing getting faulty on this side. There is the chips. So you can replace the cells, but actually you can't. You cannot do it, because they protect this battery. You know, let's say if anyone want to copy the battery and replicate the battery, duplicate the battery, like they are doing in China. So if you cut the power down, if you try to replace a cell, this memory will get erased. Yeah, if it's getting erased, nothing will work on this motherboard. Yeah, so that's why you cannot change the cells on the battery, because at the moment when you cut down one wire, everything will be gone. Morning. So that's the thing with the battery. And also through the data pin, you have data and clock. Yeah, the battery, you know, will make a report about the battery life, or you know, the how much percentage is charged, and will send these things through to the same chip, the startup chip. So that's how the battery works. And I tried before, let's say I tried make a bridge here. You see here, make like a bridge and bring the voltage here, and yeah, you can do it. Yeah, you'll have voltage on the other side. Yeah, the laptop will work but will not charge. Yeah, they are smart. So you'll make the easy to reprogram. I don't know, but if you find a way, just let me know. You know, but it's no point. You know how much is a battery? Like 10 pounds on eBay. It's not even point to bother with this thing, because it's cheap. But I tried before. Even, yeah, I open another battery. Yeah, I solder the wires. You know, the each wire. I solder the each wire, and with the elements and everything, and I try to take these cells down. You see, are batteries which are rare, and doesn't work. I don't know why. I think when the cells are faulty and are reported faulty by the power management chip, probably is no way to go back and this chip treat the battery like a good one. But that's the battery. That's the thing. Okay. Let's speak about the power supplies. Yeah, because there are most of the problems on the power supply. So on the power supply, you have the Mosfet. 4 pins all together. Yeah, it's like on schematics. Yeah, it's like on schematics. Plus, and from here you have that freak ceramic capacitors. Ah, sorry, here is the ground. Yeah, I tried. I tried to connect the battery and remove the other one. But actually the battery was still faulty, or saying consider replacing the battery or something like that. I don't remember exactly. So on the plus, yeah, on the 19, you have the ceramic capacitors, you have the Mosfet. So it's a good idea to see this Mosfet like a switch. Yeah, that's a good idea. You'll understand the things more easy. Here and from here, you have the other Mosfet. Okay, yeah. And that's the ground. Okay, from the middle we have the coil, the big round coil, yeah. And on the output we have the big capacitor, which is an electrolytic one, yeah. So the capacitor has plus and minus, goes to the ground, and that's our power supply. And you have the feedback, yeah, that's a different story. And here you have the chip, yeah, that's the phase detector, that's the gate, and you have one more gate from here, yeah, that's the gate. That's how these chips, they can get switched, yeah. So applying voltage on this pin will make the chip switching, yeah. How this is switching? Let me explain you. Let's say you have the wave, yeah. The wave on this chip is like that. Yeah, that's one cycle, one full cycle of this thing, yeah. On the other chip, yeah, on same thing, you have something like that. And this is a cycle. We're done and wrong. But anyway, yeah, that's a cycle. So most of the time the signal is 0 on the pin, yeah? You can see 0. And at some point will be signal there. Stray signal, short, yeah? When this signal will be in this pin, this will be open and the flow will be like that, yeah? Short will be open, get close, yeah? On the other hand, on the other chip, yeah, will be open when this is closed. So when this chip, the top chip, will be closed, this will be open and will carry the power on this way. Switching this coil up down, you know, will create here voltage. So that's how the things works. How many times this happen? How many times? Probably like 40 times, 40,000 times per second. So it's like 40k per second, yeah, per second. based on the feedback, which is from here, feedback, the voltage from here can be maintained even if you have 1 amp or you have 10 amps here, you know, requirement, or if you have here, let's say we have 19 volts or we have 10 volts on the input, yeah. So even if you have 10 or 19 and here the requirement is 1 amp or 10 amps, these things, yeah, changing the size of this, yeah, changing the time when this when this MOSFET is on, yeah, let's say I need more voltage, or let's say the voltage is low, so this will be more open here, yeah, and also this will go, it will be more open. So opening more these things will create me here more voltage or more amps. Okay, that's not hard. So that's the things how they work. If I have high voltage and I have no requirements, this can be even short. It can be like a short thing. So that was this chip is doing. That's you know, it's modifying the wave shape, not the shape, the time. That's how a power supply is working. But like how I said, the problems are on this capacitor, because all this switching here are like high currents, you know, all this switching will be even here. That's the reason why these capacitors are here, to cut down all these like spikes, because all this what signal I will have here, the signal will be something like that. That's my signal. Here will be like a line after the coil, yeah, but before will be something like that, and even here will be low but will still be here, and this capacitor are meant to cut down. And finally I have here, I have no more you know, signals from these MOSFETs. That's why these capacitors are here. That's why this capacitor is here, to straight my DC. So if here I have AC, obviously I have AC because that's AC, here I have DC. Okay, that's how the power supply is working on a laptop. It's not hard, it's easy. I told you it's easy. Okay, that's all what I have to say about the laptops. Going back to the first one, that's the principle of most of the laptops. Yeah, so probably this and the other video from yesterday with the laptops will give you like a clear image of the motherboard and how the motherboard is working and what it's doing. Okay, I think I have to go now for lunch, but anyway, thank you for watching. If you have any questions, we'll see for the next Friday what we can do, and have a nice weekend and see you later. Thank you. Bye.